Hello, my name is Ross Nelson with Protocol Insight. In our technical demonstration today, we will be going over useful tools and tips to analyze a UFS trace and the underlying UniPro link layer. Protocol Insight is the market leader for UFS and UniPro protocol analysis and generation. We have been shipping debug and analysis tools since 2014. The new C-Series is now shipping with UFS 3.1 support, and it will be upgradable to UFS 4.0 this fall. To begin, I will go to the application software and I will open a previously captured trace. When the trace is opened, you will see in our application software several different display windows for analyzing information. In the center top section, you can see that we have a traffic overview window. The traffic overview window will list all of the different packet types that were found in the trace for UniPro and all of the different packet types found in the trace for UFS. And you can go to any one of these packets by simply selecting one of those packets and then clicking Go. In the center lower part of our application software, you can see the listing windows for UniPro and UFS packets. The listing window represents each packet as a row. If you were to look at this PACP capability extension 2, for example, you can click on it and then you can scroll to the right and you can see more information about that packet. You can also display additional information by right-clicking on any of the headers, and you can turn on additional columns, and those columns will be displayed in the packet list window. Any of the columns can be resized by grabbing and stretching them, or just by double-clicking on the border. If you go to the UFS packet list window, it is structured in the same way. Any row is a single packet, and you can see different information in columns. If you right-click, you can turn on many additional columns that you would like to have displayed in the listing window. Within the packet list windows, you can easily navigate. We provide several bookmarks as defaults, B1 and B2. You can drag those anywhere in the packet list window to mark any packet that you're interested in. But you can also right-click and you can add additional bookmarks of your own, where you can put in your own language and you can select your own color for that bookmark. If you would like to annotate a specific packet, you can create a bookmark, select lock, and then it will lock this bookmark to that packet so that it can never be moved. Then you can add a comment in this field, and when you say OK, if you mouse over that bookmark, you can see that comment. If you put lots of different comments into your traces by adding bookmarks, you can go to any one of those bookmarks by right-clicking and going to Test 1, and you can see Test 1 is displayed. If you would like to see all of the bookmarks in this trace and all of the comments, you can come up to View the bookmark list, and then it will show you every single bookmark, Test 1, B1, B2, Test 2, and then any information about that bookmark, including the comments. So this is how you can annotate individual packets in your trace permanently. Any time that you select a row to select an active packet, the packet decode window will display in a packet format, either 8, 16, or 32 bits wide, that specific packet. If you mouse over any field, you can see specific information. For example, this transaction code is a query response. The query function was a standard read request. If you want to see the raw data view of that packet, we represent that in the data view below. You can select either hexadecimal or ASCII, and then you can select that packet data and copy it, and then you can paste that into any other tools. Another way that you can analyze the trace is by using analysis tools like trace validation. Trace validation is algorithmic approach to analyzing a trace by walking through the trace and looking for specific criteria that have been defined in the trace validation test. We provide different types of tests for UniPro and for UFS. If we select UniPro, for example, you can see that we offer a wide range of CTS tests that you can run against your trace. We also provide a wide range of different debug tests that you can run. For example, if you wanted to look at the link startup sequence in this trace, if you select the link startup sequence trace validation test, and then come up here and select Start Trace Validation, you will see that it's analyzing the entire trace and looking for all link startups in this trace. The results are displayed in the Trace Validation Results window. You can see here, if you sort by test ID, that it found quite a few different link startup sequences in this trace. For any link startup sequence, it will evaluate if the link startup sequence was valid or not. If it was, it will mark it as a pass. You can see here, by clicking on the status, that there were only passes. There were no failures in this trace. If there were failures, you would see the option to filter on a red X. But you can look at any given link startup sequence to see that link startup sequence. If you expand that test, you can click on the first message and it will take you to the first trig UPR0 that it found. Then if you use the down arrow keys, it will take you to the first trig UPR0 in the other direction after the end of burst. And you can walk through the link startup sequence in the trace by clicking down on the down arrow as you move through the UniPro compliant link startup sequence. And what you can see here is at the very end, it says it found all 4 AFC packets. Well, the last thing that happens in a link startup sequence is the transmission of 4 AFC packets. And you can see here's 1, 2, 3, 4 AFC packets. And so that link startup sequence was a success. This is an example of how you could use trace validation to analyze the UniPro level of the trace that you've captured. You can do the same thing to analyze the UFS packets. If you go to the configuration window and you select UFS, you can see that we also provide a large number of UFS CTS test cases and UFS debug test cases. For example, if I were to run a command response latency test, this trace validation test will analyze the trace and it will look for every UFS command packet and then measure the latency between the command and the response. So I'm going to run this test now, and it is now analyzing this trace, and it is looking for all command and response packets in the trace. You can see that it's already found over 800 command response pairs in this trace. If I remove the test filter, I can start at the very top of the packet trace, and I can see that it found a command packet. If I select it, it takes me to a test unit ready. If I select the response, it will take me to the response packet. You can step through to each command and response trace that it found in the packet. But you can see here that we are also measuring latency. So this command packet here, if I were to put my B1 bookmark on, and then if I put my B2 bookmark on the response, you can see that the latency between B2 and B1 is 719 microseconds, which is what we are showing in this message here. So you can measure latency between packets by using bookmarks and the timing measurements within the bookmark tooltips, or you can run a trace validation test and it will analyze each command and response packet and provide the latency for each. So that's an example of how you can use the trace validation analysis tool to measure a wide range of different things within the trace without having to individually measure single packets at a time in the packet list window. I hope that this technical demonstration has been useful.